So the first glands of the endocrine system that we're going to talk about are the pituitary gland and the hypothalamus. Now, remember when we talked about the brain in chapter 12, we talked about the pituitary gland. It's a small little gland that is suspended from a little stalk, and above it is the hypothalamus. So I'll show you a little picture here. Remember, we looked at things like the thalamus, and then right in front of it, this purple structure, that is the hypothalamus. And then here's that little stalk, and here's the pituitary gland. Okay, if we look at this little image right here, this box is just blowing up the hypothalamus and the pituitary gland a lot bigger, so you can see it a little bit better. There's two parts to the pituitary gland. Because it releases so many hormones, it's divided into an anterior or a front half and a posterior or a back half. So again, if we look at this picture, you can see here the pituitary gland. You can see it's been divided into an anterior, which is all in this red color, and you can see all of the different hormones that are released from the anterior pituitary gland. And then the posterior pituitary in yellow and all of its hormones. So we're going to walk through all of these hormones that are coming from the pituitary gland. But before we do that, I want to talk about the relationship of the pituitary and the hypothalamus. So the hypothalamus is basically the boss of the pituitary gland. And the reason is because the hypothalamus is constantly monitoring your blood. Remember, there is no blood-brain barrier within the hypothalamus. The hypothalamus is heavily involved in homeostasis. Okay, we talked about that in chapter 12. So it's constantly monitoring your blood, and it's looking at levels of hormones in the blood. It's looking at nutrient levels in the blood and ion concentrations in the blood. Anytime your hypothalamus notices that something is off, if it's out of balance, it's going to activate that hypothalamus to secrete hormones that travel to the pituitary gland. So this is how, remember, hormones are how your organs communicate with each other. And this is how the hypothalamus communicates with the pituitary gland. It is the boss of the pituitary. And so your hypothalamus monitors the blood. If it notices that something is off, maybe a hormone is low, it will release a hormone that travels to the pituitary gland. Now, the hypothalamus can release two different hormones. It can release what's called a releasing hormone, which is going to stimulate the pituitary to release a hormone, or it can release an inhibiting hormone, which would inhibit the release of hormones from the pituitary gland. Okay, so let's go back to that example. Let's say that you have a hormone in the body that is low, and you need more of it. The hypothalamus would release a releasing hormone, which travels to the pituitary and tells the pituitary, hey, make more of that hormone. On the flip side of that, let's say that hormone level is high, it's elevated, you need less of it. The hypothalamus would recognize that and say, oh gosh, we got too much of that hormone, at which point it would release an inhibiting hormone, which travels through the pituitary gland and tells it, do not make any more of that hormone, we have too much. And so this is how the hypothalamus is the boss of the pituitary gland. So let's walk through the anterior pituitary and the 6 hormones that are released from that portion of the gland. So we're going to talk about the growth hormone and what it does. We'll talk about the thyroid-stimulating hormone, the adrenocorticotropic hormone, gonadotropins, and finally we'll talk about prolactin. Okay. So we're going to start off with the growth hormone. This is an anabolic hormone. So remember the term anabolic. This refers to reactions. We have anabolic and catabolic. Catabolic is a breakdown reaction. Anabolic is a build-up. Think anabolic steroids. So growth hormone is an anabolic hormone, and it's going to stimulate your cells and your tissues to grow. And that term that refers to that is called hypertrophy. One thing that the growth hormone is going to do other than stimulate cell and tissue growth is it also accelerates fat catabolism. So remember, catabolism is breakdown. So it actually accelerates the breakdown of fat, and it slows down glucose breakdown. And so by doing this, by slowing down glucose breakdown, it causes blood sugar levels to be a little elevated. We call that hyperglycemia, and that can help with growth. Now, some of the indirect actions on growth that we find with a growth hormone, typically it's going to target bone and skeletal muscle. Okay, so this is a hormone that will get released throughout your life, but mostly it is found in higher levels in young children that are growing. Okay, once they hit puberty, it's no longer the growth hormone that's really triggering those big growth spurts, but instead it's sex hormones like estrogen and testosterone. What will happen is tissues will produce something called an insulin-like growth factor in response to this growth hormone. And that insulin-like growth factor is going to stimulate those local tissues to start growing. So this is actually showing you, this one's pretty interesting. It's showing you the cyclical changes in growth hormone throughout the day. So a couple things I want to point out here. So you can see that in this sort of orange color, this is daytime. And so you can see that during the day, it is going to cycle a little bit during the day. But notice what happens when you exercise. You release growth hormone when you exercise. Now let's go back here, because remember, one of the major targets of growth hormone is bone and skeletal muscle. So whether you are doing cardiovascular activity or whether you are lifting weights, you're going to increase your bone mass, you're going to increase your skeletal muscle. So that's why you'll see a spike in the growth hormone there. And then at night, so notice in blue, this is all night. This is when you're sleeping. And there is also a spike in growth hormone at night. That's very common, especially with children. So I know with my son, especially when he was really little, and even now, I feel like I put him to bed in his little Ninja Turtle jammies, and he wakes up the next morning and he looks like the Incredible Hulk. Like, they're high waters, they're way too high for him, they're way too small for him, and kids will hit those growth spurts and they'll release a lot of that growth hormone at night when they're sleeping. Now, as we age, growth hormone will start to decline. We lose a lot of that as we age. Now remember, growth hormone release from the pituitary gland is regulated by the hypothalamus. Remember, the hypothalamus is always the boss. And the hypothalamus, I told you earlier, only releases two kinds of hormones. It will release a releasing hormone or an inhibiting hormone. That's it. And so when it comes to growth hormone, the hypothalamus releases a growth hormone releasing hormone or a growth hormone inhibiting hormone. Okay, the releasing hormone will stimulate the release of growth hormone. The inhibiting hormone will stop the release of it. Also, growth hormone release can be stimulated through the nervous system. And so this is why on that previous slide, you could see things like exercise stimulating growth hormone. Anytime there is a deficiency or excess growth hormone, there's going to be dramatic changes in the shape of the body. So here are some examples of that. If there is excess growth hormone released during the growth phase, so when you're actively growing, excess hormone causes a condition called gigantism. So you can see here, these two boys, yep, I said boys, they are the same exact age. So they are still actively growing, but you can see this one clearly has gigantism. Is that an oversecretion of growth hormone? An undersecretion of growth hormone during the growth phase leads to dwarfism. Okay, so you can see that here. After you're done growing, so when you're for females, usually we're done growing by the time we're about 17. Males can continue to grow into their early 20s, but after your growth phase, if there is an oversecretion of growth hormone, it leads to a condition called acromegaly. So you can see this image over here on the right. There's a little girl and it looks like she's developing completely normally. And then after she's done growing, she's continuing to release that growth hormone and it causes very coarse facial features. The hands become very large and swollen. It leads to a hunchback, a very large tongue, kidneys, liver, and other internal organs. Another hormone that's coming from the anterior pituitary is the thyroid-stimulating hormone. We call this for short TSH, and this one stimulates the thyroid to produce hormones. So let's go back to what we talked about at the very beginning of this lecture. We talked about tropic versus non-tropic hormones. So a tropic hormone, remember, stimulates the synthesis and release of other hormones. So we would say that the thyroid stimulating hormone is a tropic hormone. It is released from the pituitary gland, it travels to the thyroid and tells the thyroid to release other hormones. And the other hormones that get released are called thyroxine and triiodothyronine, which I know is a mouthful. So a lot of times we just call these T4 and T3. Now, the main function of these thyroid hormones is to stimulate the breakdown of glucose by your body cells. So this actually helps to produce energy and it produces body heat. And we will talk more about T3 and T4 towards the end of this chapter. Now, remember, the thyroid stimulating hormone being released from your pituitary gland is controlled by the boss, which is the hypothalamus. So when this hormone needs to be released, the hypothalamus releases thyroid stimulating hormone, releasing hormone. Your hypothalamus would release that anytime there's low levels of T3 or T4, or when you're cold. That should make sense. If you think about what T3 and T4 do, they stimulate the breakdown of glucose, which produces energy and heat. So if you're cold, that's going to trigger you to make and produce more T3, T4, so you can generate more heat. And also stress would cause this as well. Another hormone coming from the anterior pituitary is called the Adrenocorticotropic hormone. For short, we call it ACTH. And this one stimulates the release of another hormone called glucocorticoids from the adrenal cortex. So this is also considered a tropic hormone, just like thyroid stimulating hormone. Now we'll talk more about glucocorticoids toward the end of the chapter, but these are steroids that increase blood sugar levels to help with homeostasis. How they can increase blood sugar levels is they can stimulate something called gluconeogenesis. So if we break that word down, gluco means glucose, neo, think neonatal, neo means new, and genesis is the beginning of. So literally, the beginning of new glucose or glucose formation. Another way that glucocorticoids can increase blood sugar levels is by preventing the uptake of sugar, or they can increase some of the other nutrients that can be used in cell respiration. So remember, when I think of cell respiration, I always think of this equation: carbs or glucose plus oxygen forms CO2, water, and energy. But in reality, if you don't have enough carbs, let's say that we take glucose out of the equation, then the next thing that your body would use would be lipids, so fatty acids. And if you don't have lipids, the next thing your body would use is amino acids or proteins. And so that's why when they increase glucose levels, one of the things they can do to increase glucose levels and keep glucose in the blood is prevent it from being turned into ATP. So by using lipids to create energy or amino acids to create energy. Now again, remember, all the hormones that come from the pituitary gland, these are all controlled by the boss, which is the hypothalamus. So The adrenocorticotropic hormone is controlled by the release of a releasing hormone coming from the hypothalamus called adrenocorticotropic hormone releasing hormone. And this is going to get released anytime there's low levels of glucocorticoids in the blood or even in response to stress. And then another hormone that we find coming from your pituitary gland are gonadotropins. Gonadotropins are, if I think of the word gonad, the gonads in the male are the testes, and the gonads in the female are the ovaries. And so reproduction in both men and women is really under the control of the pituitary gland and the release of those gonadotropins. Now, the gonadotropins that we'll talk more about are follicle stimulating hormone, which we call FSH for short, and luteinizing hormone, LH. These play a role in both men and women. Follicle stimulating hormone in women helps to create more eggs each month to be ovulated. In men, follicle stimulating hormone helps to create more sperm. So let's talk a little bit about these hormones. Again, follicle stimulating hormone just is something that is initiating those in females, the ovarian follicles, so that a woman can release more eggs each month. It also stimulates estrogen secretion, and in a man, it's going to stimulate sperm production. So in a woman who is undergoing fertility treatments, one type of treatment is an injection each month with follicle stimulating hormone. If a man has fertility issues, maybe has a low sperm count, he can do the same. He can do an injection of follicle stimulating hormone each month to increase sperm production. Now, follicle stimulating hormone is absent in boys and girls who have not gone through puberty yet. That makes sense. Until a girl begins menstruating, she is not ovulating. She's not releasing any eggs. But then there's also another gonadotropin called luteinizing hormone, which we call LH for short. This one acts with follicle stimulating hormone, and it stimulates estrogen secretion. This is also another hormone for women that actually triggers ovulation. So when a woman gets ready to ovulate during her cycle, there's a huge spike in LH. The other thing that luteinizing hormone does is when a woman gets pregnant, it helps to stimulate the release of progesterone. And remember, I mentioned to you at the very beginning of this lecture that progesterone maintains the uterine lining. So this is a hormone that's released when you're pregnant, saying, hey, we need to make sure we're releasing enough progesterone to keep that lining intact and keep that pregnancy viable. It can also increase testosterone secretion in a male. The last hormone that I'm going to walk you through that's part of the anterior pituitary is prolactin. Prolactin, when I see that word, I see lact, and I always think of milk. So this is the hormone that stimulates milk production in the breasts. Milk production and secretion is controlled by a neuroendocrine reflex. And so what that means is it's not just about having prolactin present. It's not just about this endocrine, this hormone being present, but it's also a nervous system reflex. And one of the big things that you have to have in order to continue making prolactin is suckling. So whether you are, after you've had your baby, whether you are pumping or you are breastfeeding the baby, there has to be the stimulation, the nervous system stimulation of the nipples in order to continue producing prolactin and continue making milk. So prolactin production will continue as long as suckling continues. Now, a baby will naturally wean as you start feeding a baby solid foods. They'll need less and less breast milk, in which case they'll suckle less and you'll make more milk slowly over time. Now, women who don't nurse at all after they've had their baby and go straight to formula, they'll produce prolactin. Their breasts will fill up with breast milk. But if there's no suckling, then prolactin levels will very quickly decline and that milk will dry up. Hypersecretion of milk is much more common than hyposecretion. Nobody complains about not producing breast milk unless they're trying to nurse. So a mom who is trying to nurse a baby who isn't making enough milk, this can be a big problem, but otherwise it's not something that anyone would ever complain about. Instead, what you would complain about is if you're making breast milk when you don't need to be making breast milk. And so we call that hyperprolactinemia. It is when people are producing prolactin when they shouldn't be. And this can be an indication of a tumor in the anterior pituitary gland. And so this would result in, again, producing breast milk when you shouldn't be. Maybe you haven't even had a baby and you're producing breast milk. It can cause you to stop having a period, so a lack of menses. It can lead to infertility in males and females. And this is something that males can release as well. So if males are releasing prolactin, it can result in fertility issues and impotence, and obviously inappropriate lactation. So those are all of the hormones from the anterior pituitary that we just walked through. Now we're going to walk through some of the hormones that come from the posterior pituitary gland. And there's two hormones I'm going to walk you through. There's the antidiuretic hormone and oxytocin. So the antidiuretic hormone, this is a hormone that helps to increase water absorption in the kidneys. So think about the word diuretic. A diuretic, when someone takes a diuretic, it makes them have to urinate. And now think of this prefix here, anti. So an antidiuretic would make you not urinate. So again, this is a hormone that when it's released, it causes you to absorb more water from your kidneys. You put the water back in your bloodstream, and if it's not coming out in your urine, that means you're not urinating very much. It's going to cause the urine that you do produce to be very concentrated. It's going to have a really strong odor. It's going to be really dark in color, and it's not going to have much water in it. Now, the secretion of the antidiuretic hormone is, again, controlled by the hypothalamus. Notice every one of these hormones we've talked about that come from the pituitary, they're all controlled by the hypothalamus. So the hypothalamus, remember, is constantly monitoring your blood. It is looking at the hormone levels in your blood, and in this case, it's looking at ion concentrations. When ion levels become high, this is usually because it's too concentrated. You don't have enough water. So when ion levels become high because you're dehydrated, the antidiuretic hormone will be released into the bloodstream. So an example of this might be, if you've gone all day and you're watching this video and you've had maybe a cup of coffee and a Diet Coke all day, you're probably not going to the bathroom very much. And when you do go, it's probably very yellow and it has a strong odor to it. It's very concentrated. You are releasing the antidiuretic hormone. You are not urinating out water. You're saving it and putting it back in your bloodstream because you are dehydrated. Now, on the opposite end of that would be, let's say you're drinking 60 ounces of water a day. You're drinking a ton of water. You're very well hydrated. You're not releasing the antidiuretic hormone. Instead, your kidneys are doing their job. They're getting rid of the excess water. It's coming out in your urine. But that also means you probably run into the bathroom pretty often. Your urine should be very clear, and it probably doesn't have much smell to it. Now, the antidiuretic hormone, again, you release this when you're dehydrated. This one gets inhibited by alcohol. So, when you drink alcohol, a lot of times you have to pee a lot. You'll go to the bathroom constantly. And if you drink too much alcohol, the next morning you wake up with a terrible headache. Your mouth is really dry, like you've been sucking on cotton. You don't feel good at all. All of that is because of severe dehydration. Your mouth is dry, you have a really bad headache. So the best thing you can do is rehydrate yourself. The other hormone that comes from the posterior pituitary that I want to walk you through is oxytocin. Oxytocin is a hormone that does a couple of things. It's heavily involved in childbirth. It's also heavily involved in breastfeeding. So oxytocin does not produce milk, that's prolactin. But oxytocin can stimulate the ejection of milk from the breasts after suckling begins. So again, prolactin causes you to make the milk, but oxytocin helps the milk pump out of the breast. So I nursed my son for a long time. It felt like forever. And I remembered you being a new mom, I didn't really know what to expect. And he was maybe a month old, and we had a cat at the time. And every time my son would cry, I would leak milk because that oxytocin would be released. So your brain gets so used to when you hear the baby cry, you release oxytocin. So you're probably wondering where the cat comes into play here. My cat would walk around the house and meow. He was very vocal. And it got to the point where my cat would meow and I would start leaking breast milk from the cat meowing. So any kind of cry that I heard, any other baby crying, my baby crying, even the cat meowing, and my body would release that oxytocin and it would cause the milk to be ejected. So this one is typically stimulated by suckling. Oxytocin is also heavily involved in childbirth. So it actually stimulates the smooth muscle in the uterus to contract during childbirth. So what will happen when a woman goes into labor is the pituitary will release a little bit of oxytocin, and that causes a little bit of contraction, and that'll push the baby down. They'll actually move down into the cervix, and they'll start stretching and pushing on the cervix. The cervix is then going to send signals back up to the hypothalamus, say we need more oxytocin. Oxytocin gets released, causes more contractions, which pushes the baby further down into the cervix. And so this is an example of positive feedback. So this is not negative feedback, but this is positive feedback. And remember, we talked about positive feedback at the beginning of the semester and how this one is very different from negative feedback. With positive feedback, you keep going in the same direction as the initial change until there is an end. So with labor, your contractions get stronger and stronger and closer together until you deliver the baby.